Alright, here's the back side of this polynomial intro ditto. And this one's going to be a little bit tricky. First thing I'm going to do before we start sketching, because on the other side we wrote equations, and this side is just going backwards drawing a graph, we need to know a pattern. And I'm going to jot down here the old traditional parabola, which we all know looks like this, versus a parabola that has a negative a value, which looks like this. Now, I'm headed towards showing you a pattern we need to recognize. I'm just showing you some graphs that we know. The old cubic graph, if you remember, looks something like that, versus the flipped version, looks like that. And here's the pattern we need to get out of this. When the a value, which is that number right there, is negative, then the graph, as it exits to the right, meaning that guy right there, it exits going down. When it's positive, the graph exits going to the right, headed up. That's the pattern. I'm just talking about the far right. This doesn't have anything to do with the far left, but on the far right, if that a value is negative, then the graph is headed downward. Now, we need to know that when we're drawing the graphs, and that's what we're about to do here on the back side, problem number 6. So, problem number 6, the first thing I can put on here are the x-intercepts. I know that guy's x-intercept is a positive 4, so I'll put a dot at 4. And the x-intercept from that is 2. And the x-intercept from a plane x, that would mean a 0, right? If we were to put 0 right here, you would have 3 answers, 0, 2, and 4. And that's what I put on my graph here. The shortcut I just showed you, that pattern, I guess you should say, not really a shortcut, is how does the graph exit when it leaves the last x-intercept? Is it headed upward or is it headed downward? And what we used is the a value. The a value is the number in front of this equation, and in this case, there's nothing there. That means it's a positive 1. And since it's positive, this graph's going to leave the last x-intercept heading up. So that may be kind of weird. I'll do a few more. But this graph heads up because that's positive 1. Now, so I'm just going to sketch something, and that's why it just says sketch here. So sketch something, so the graph's headed up. When I get to this 4, which I put there because of this guy, it has an exponent of a 1. And because it's a 1, I go straight through. I don't bounce off, and I don't do the cubic bend. Those are my other 2 options. So I head straight through it, and when I get about halfway between these 2, I have to turn and head back. And as I head towards 2, which I put on there because of this guy, I take a look at the exponent, it's a 1, and I go straight through. Then I get about halfway to the next x-intercept, and I turn and I come back, and I put that dot there because of that x, its exponent is a 1, which means I go straight through. And that's my sketch. I got my 3 x-intercepts that I knew, and the positive 1 tells me my graph has to head going up as it goes to the right. I don't care about the left side. There's no pattern for the left side. Alright, let's take a look at B. I'm going to go put my x-intercepts on the graph first. So x squared means I have a 0. X plus 5 means I have a negative 5. And x minus 3 means I have a positive 3. My graph is going to exit the last dot headed upward because there's a positive 1 a value. So I'm going to head upward as I leave that last x-intercept. Alright, so when I get to this 3, which I put there because of this, the exponent is a 1, I go straight through. About halfway between those, I stop. You'll notice the y-axis is not labeled, and that's because we don't know what that is. That guy right there could be negative 1,000, it could be negative 1,000,000, it could be negative 4. Since we're just sketching, I don't care what it is. I don't want you to worry about having to be accurate. That's why there's no tick marks on the y-axis. halfway here, we're going to turn and we're going to head back. Now, I put this dot there because of x squared. That's why I put it there. And since it's a squared, I have to bounce off, or form a parabola, if you will. So I'm going to bounce off, rather than go straight through. So bounce off because of the squared, head this way, about halfway, start to turn, and when I get to the -5, which I put there because of that binomial, that's a 1, I'm just going to go straight through. Alright, let's try C. Let's go put the x-intercepts on there, which are the same. You'll notice there's a 0, and a -5, and a 3. So the only difference between these two is this value right there, this A value, which is negative. That means this graph's going to leave the last x-intercept headed downward. So I need to draw something that's headed down. 3, I put it there because of this guy, which has an exponent of a 1, which means you go straight through. And you turn and you head towards the 0 value, which I put there because of x squared, but because it's squared, I'm going to bounce off. And when I get halfway, I'm going to turn and head towards the -5, which I put because of that guy, which has a 1, and because it's a 1, I go straight through. And what you'll notice, it is just this graph flipped. That's all that negative did, was flip the graph over. Alright. I'm going to leave D for you to try. You can check the answer key if you want to check. Let's head to question 7E. 7E is going to make you grumble because it's going to ask you to sketch reasonable graphs, but these equations aren't factored. You have to factor all these. I hope you just grumbled because that made me happy. So we factor these using your factoring skills. Once we factor these, it's going to turn into problems that look like the ones we just did up above. For example, on E here, we factor first by taking out an x squared from both of those items, which would leave that. Then we factored the x squared minus 9 farther, and it factors to an x minus 3 and an x plus 3. So once you get it factored, it's the same rules as the problems up above. We place the x-intercepts on the graph, so we've got a 0 because of the x squared, we've got a 3, and we have a -3. The A value, or the number that's right there, is 1. You could even use the A value that's in the original problem, which is also 1. They're both 1s, means the graph's headed upward as it leaves this last x-intercept. So it's headed up. When I get to this 3, which I put there because of x minus 3, I pass straight through. Then I turn and I head towards this 0 value, which I put because of this x squared. Because it's a squared, I know I'm going to bounce off. And then when I head towards this -3, which I put there because of this x plus 3, which has an exponent of a 1, I'm going to go straight through. So this one kind of looks like a W. And that's that graph. This is a good one for you to try. Let's take a look at G. G says we need to factor first, and hopefully you factor out a negative sign and an x sign, and that way you don't have to factor with a negative. And if I pull out a negative x from each of those, the signs change, and then I can factor that again. And now we're ready to graph. My x-intercepts are -4, 0, and 1. And this negative, or this negative, or this negative right here tells you that the graph is exiting headed downward. You'll notice all of the exponents are 1s. And if you know that ahead of time, then I just know that it's gonna head downward, and it's gonna pass through all of my x-intercepts. And you just kind of eyeball halfway through, come back, halfway through, come back, and just kind of eyeball it. But they all go straight through, so that one's kind of friendly. Alright. H is a good one to try. I wonder how much time I'm at. I'm going to pause that video, stop that video.